Welcome to our presentation on scaling objects for the enterprise. What if thousands of VMs could share terabytes of objects? And this is a discussion on GemStone. My name is James Foster. I work with GemStone systems, and I've been a computer programmer off and on since the early 70s. So been playing with this for a while. So we'll start with what is GemStone, what's the architecture, and what are some of the goals in it. Is it a small talk system, a database system? Well, it's two in one. So got both of those things. In GemStone, we have a virtual machine that compiles source code to byte codes, and then compiles it to machine code just in time, so as it's being executed. JIT compiler. And then there's an object manager that treats the entire repository, all of the disk space that's been devoted to GemStone, as object space, or as an image for your system. So in-memory garbage collection then reclaims the space used by unreferenced objects. So as compared to the typical traditional client Smalltalk, as much as will fit in RAM, but here with GemStone we get as much as will fit on disk. So you can put as much memory, as much disk as you want, and you can fill objects. The database system, transactional persistence, we'll go into details on each of these things. Transactional persistence, multi-user, multi-machine, garbage collection for persistent objects that are no longer referenced. So these are going to be some of the things we look at now. So a very high-level architecture for GemStone. We have what we call gems, that's the virtual machine. The virtual machine, you can have one or more virtual machines, or gems. They connect to the stone, communicate with the stone, and then the repository is on disk to hold the objects. In addition to those components, we have other components that are built into the system that are there not simply so that you can run Smalltalk and have objects, but to support some ancillary goals. Time efficiencies. So it takes a while to read things from disk. So we have a shared page cache. That is, we can load things into memory from disk and cache it in memory. Robustness, recoverability. We don't want to lose things if the system crashes. So we have transaction logs, or replay, redo logs. This is similar to any other conventional database system. Then, of course, space efficiencies. You create objects and then you release objects. Once you've released the objects, they still take up space until you've done garbage collection. So it's that garbage collection that will then free them up.